So, thank you very much. So, good afternoon, everyone. Hope you're enjoying the day so far. It just started, so there is a lot going on out there. Hopefully, you enjoyed this talk as well. So yeah, I thought we could spend some time today talking about science and fiction in relation to TV series and films, and how much is true or how much is just fantasy. And of course, there are cases where you have stories which have a very strong fictional element, stories where they try their best to keep the scientific accuracy there, and things which are in between. And of course, in that case, filmmakers must be a very big effort in order to kind of combine the two things so that they can tell a very entertaining story while still have this scientific accuracy. So I love space. I work with, as an engineer, I work with space technology and lasers. So for me, one story which I really love is Star Wars. Star Wars is full of incredible technology. They got things like robots, actually droids, and lightsabers. And you might think that some of those things we are pretty close to get them. And in some cases that might be true. This might be the case of droids, or in this case, humanoid robots. This is the example from Boston Dynamics, who are making these very advanced robots that can do lots of incredible things. This is not even the latest model. Those things can actually walk, do cartwheels, they can do headstands and so on, though they don't have hands, in fact. So we are moving in that direction in that sense. But if we had to think about lightsabers, that's a little bit different. So lightsabers are meant to be, in a way, swords or lasers. But if we had to use lasers, it would be difficult to have a real duel. It would be not so interesting. There would be no interaction between the laser beams. So not really a big thing. So a way to go around this could be to have to use instead plasma. So plasma is a very hot ionized gas. You could use that to make the battle a little bit more fun. But that's not really achievable because you would need to bring with you some source of gas all the time, and then a high power source as well, which wouldn't be batteries, so you need to be plugged into the main all the time. So not really portable, not really fun, and hopefully we'll never need to develop anything like this, of course, unless just for fun. Still on the theme of space and Star Wars, another element of those films is explosions in space. Often you see those battles where large spaceships or small spaceships, they kind of get hit by something and they explode in place, very loud. And of course, that's not really something that might happen in reality. So one thing is sound. Sound needs something to propagate in space. There is no air, so there is nothing to propagate through, and so there would be no sound. An explosion like this would be really quiet. And also, in the films, those spaceships explode in kind of a localized way. They stay there. In reality, those explosions will actually lead to a very big cloud of debris flying everywhere, and all moving in the same trajectory as the initial body, like orbiting a planet, and so it wouldn't be localized. And one final thing would be the way fire propagates. Flames behave differently in space, of course. One reason is the lack of gravity or the presence of microgravity in another way. So that's a picture of an experiment from NASA where they compare the classical flame on the right on Earth and then the more like spherical flame which you would see in space. So quite a few differences. Still on the theme of space, of course, another example that comes to my mind is Star Trek. Star Trek is very different, of course, from Star Wars. It's a lot more about exploration, meeting more or less friendly alien species, and so going around on more or less large spaceships and exploring. One thing Star Trek did really well since it was first aired in the 60s, I think, was predicting the future. So in Star Trek, they show most of the things we now use nowadays on a daily basis. To give you a few examples, so they kind of show you things like communicators in the 60s already, which we now call smartphones. They have 3D printers. They call it replicators, and they manage to replicate things instantaneously, of course, it takes some time to do that nowadays, but probably we're getting there in a way. Then we got tricorders in the series, which are basically health monitoring device. We now have health monitoring devices like smartwatches, which of course are not meant to be used for medical purpose, but we're also developing medical devices which are very small and compact, and MPL actually is helping with that. Other things they managed to portray in early in the days were tablets. They call it pads, universal translators, and then they had these voice-activated devices. They had to say, computer do this, computer do that. Nowadays we give it a name. But it's basically the same thing. Now the next thing would be a little bit less about space, more about aerospace. When I was studying aerospace engineering several years ago, I remember I got very impressed by one film that was about a superhero flying in air with an armor made of some metals, and that of course is Iron Man. But if we had to be more accurate, precise, maybe Iron Man is not the right term, better be Titanium Man or similar, just because titanium is a much better choice of material for a suit like this, and they probably say that in the first film as well. That's of course it's unofficial. When I first watched Iron Man, I remember seeing things that I was studying at the time, and I was really impressed by seeing that in the film. One thing was the fact that they had to go with the ice forming on a lifting surface when high enough in the sky. So they had this issue in the film, and I remember studying that thing. And then several years later, I worked for a company doing aerospace engines. And I had to kind of investigate that almost on a daily basis. So that was in the film, and that's something that is actually reality. And of course, while progressing with the series and with the films, things moved a bit too much towards nanotechnology, so that element of realism got a bit lost. But that's okay, it's sci-fi or fantasy. Talking about stories where they try to balance realism with fantasy, a very good example, at least for me, would be Interstellar. In Interstellar, one thing they do really well, in my opinion, is kind of showing how a black hole would look like. In the film, it's something like this, something like the picture on top, and that was actually just fantasy. It was the result of work from a big team of scientists and engineers working together with the filmmakers in order to come up with simulations based on real equations, and so the real theory behind black holes, and so eventually managed to portray this black hole in the film. And if you have to compare it with the first image, real photo of a black hole, it looks a little bit different. I see that, but just because what you see there is actually it's not the black hole itself; it's the material being ingested or digested by the black hole. So it's kind of emitting light. And that photo was actually a result of a massive work of collecting data from several telescopes around the world, merging this data and synchronizing that through atomic clocks, and then eventually obtaining something like this, almost like from a Earth-based telescope. So quite a lot of work. And then I would say there are cases where they try really hard to keep some element of scientific accuracy, and they fail a little bit, just because they want to exaggerate things. in a way that the public can actually enjoy the film a little bit more. And for me, that would be Gravity, the film. So in Gravity, lots of things happen. It's all due to gravity, of course, as the name suggests. They do a great job in kind of showing the effect of potential catastrophic events happening in space where things collide and debris are formed. The effect is exaggerated, but something like this can actually happen in reality. So almost every day, satellites in orbit around the Earth, they actually need to make some collision avoidant maneuvers because of debris flying their way or other satellites risking collision with. So that's something like it's a real thing that happens every day in terms of and posing a danger to satellites and to astronauts who actually sometimes they have to shield themselves, let's say on the ISS, in the most protected parts of the ISS, in order to avoid being hit by a little piece of debris. Even if it's a little piece of debris, the speed is such that it could cause a lot of damage. So one thing that gets exaggerated in the movie is actually something that happens in real life. And then just to finish off, I wanted to give an example of something which is not really meant to be accurate, scientifically accurate, but it's just a work of fantasy. But I like that because at some point they talk about quantum and they work with quantum stuff, and also makes me laugh. So that one is Ant-Man. In Ant-Man, they can shrink themselves a lot to the size of an ant, of course. They shrink everything, cars included. They say that they can conserve the mass of the things they shrink, then they ignore completely that, so that you can see the guy carrying around lots of Hot Wheels. It would be pretty heavy, so it's completely ignored at some point. But one thing they do at some point in the series, they shrink themselves even smaller to a subatomic level, to a point where they can enter this quantum realm. So in the quantum realm, which in their case is a fantasy world, things are not, so the laws of physics are not really the way they would expect. In the films, there is like an entire universe hiding in this quantum realm, and so it's really a fantasy world. But the quantum realm for us, working on quantum technology, is an actual thing. So if in the films this is like a place, when you're talking about quantum technologies, that's actually more like a description of a specific set of physical laws. So they both share this element where the quantum realm is a realm beyond our current understanding, where the laws of physics behave in a different way compared to what we expect. And so, yeah, it's kind of a true thing, but not a real location. So these quantum strange effects are different just because we are really tiny. So they are different from the macro world. And we can see those things in technology like optical clock or atomic clocks in general. Some of those we are developing at MPL. Of course, at MPL we don't do just quantum, we do a whole range of things. That's just a fraction of what we do. So I would say after these talks, go around, explore every lab you can find open, of course with permission, and talk to people that will be really willing to talk to you about what we are doing here. And enjoy the rest of your day.